Hey there! Let's graph linear inequalities, starting off with y equals x, which is just a regular equation. We know that y equals x would be just 0, 1, 1, and it's just this straight line in the middle of the graph. So we know that. We know that's a solid line. It's nothing special about it. It's just our basic graph. Now let's look at y is greater than x. It's an inequality, so it's different. So if we have that, let's use red here. So if we have y is greater than x, all the things are the same. We still have the same points, right? But what's different about it is that it will have a different kind of line. So instead of a solid line, because it's a less than or greater than comparative sign, we have to use a dash to mark that this isn't just a regular line, it's actually a comparative line. So let me redraw. Here's our linear inequality graph, and also another key part of it is shading, because it's an inequality, so that means, let's say x is greater than 3. The only possible points are everything greater than 3. Same thing here. So, depending on which way the operative is facing, that's which way we're going to shade it, either over here or over there. So, because it's facing y, that means it's going to be everything on top of the inequality. So let's call this top and this bottom. So, because it's y is greater than x, everything greater y will be shaded. So here, yes, this side will be shaded. If it was x is greater than y, then it'd be the bottom. Another way to check it is to plug in a point. Let's say we picked 3, 0. We'd substituted x and y, so we would get 0 is greater than 3. And we know logically that's not true, which means this point cannot be a solution. Which is another way of saying that everything up here is a solution, because it checks in to be true. Alright, so let's try another one. Let's try out y equals 2x minus 1. Let's say y is less than 2x minus 1. So, what we need to do is plug in some points. Let's have a little table here. So let's say x is 0. So if x is 0, y is negative 1. Remember, this is just like an equation. So let's say x is 2, y is 3, x is negative 1, y is negative 3. Let's plot those points and do a little graph, and it should look like that. Awesome. So another thing is that if the operators are greater than or equal or less than or equal, as long as it has that little dash on the bottom, it's a solid line because it's inclusive. That means that that point, if the point is on the line, then it can be a solution too. On the other one, it cannot. So if it's like that, it's dotted. If it's with a dash, it is a straight, solid line. So let's continue here. So, now that we have the graph, we need to find out which side of the points are the solution. Is it the top or the bottom? Well, we can easily see from here that because y is less than the graph, then all the points here are the solution. But let's plug in one. Let's say 0, 2. Let's plug it in. 2 is less than or equal to 0 minus 1. 2 is less than or equal to negative 1, and that's wrong, so we are correct. Alright, well, thank you for watching. This has been Graphing Linear Inequalities, provided to you by SATFreePractice.com.